Hi everyone, welcome back to another video. So in the last video we went through the max LED, that was the 8x8 LED matrix, and now we're moving on to the MPU-6050 module. Again, no idea what this is, so let's just open it up and have a look. Okay, lesson 15. In this lesson we will learn how to use the MPU-6050 module, which is one of the best IMU inertia measurement units. Okay, so inertia has to do with movement, right? Like I think of space objects or something. So, compatible with Arduino, IMU sensors like the MPU-6050 are used in self-balancing robots. UAVs? Oh, okay. I was thinking UFO. UAVs is what they have in Call of Duty, right? And then smartphones. Okay. So for this one, we need 4 female to male wires. The InvenSense, I don't know how to say that. The InvenSense MPU-605 sensor contains MEM's accelerometer and MEM's gyro in a single chip. It is very accurate as it contains 16-bit analog to digital conversion hardware for each channel. Therefore, it captures the X, Y, and Z channel at the same time. The sensor uses the I2C bus to interface with the Arduino. The MPU-6050 is not expensive, especially given the fact that it combines both an accelerometer and a gyro. Is it gyro or gyro? Gyro, I think it is. You guys don't watch these videos for English lessons, so forgive me. IMU sensors are one of the most inevitable type of sensors used today. Inevitable? Okay. In all kinds of electronic gadgets. They are seen in smartphones, wearables, game controllers, etc. IMU sensors help us in getting the attitude of an object attached to the sensor in three-dimensional space. Okay, I don't know what those words mean. These values, usually in angles, thus help us to determine its attitude. Attitude? Okay. Do we mean altitude here, or are we just saying attitude? Like, do these gadgets have a personality? Are they divas? Thus, they are used in smartphones to detect its orientation, okay, and also in wearable gadgets like the Nike Fuel Band or Fitbit, which use IMU sensors to track movement. Bit of advertising there. Okay, so this is more about how they work. I must say that's a lot of text that I can't bother to read. Let's just read, a sentence. IMU sensors usually consist of 2 or more parts, listing them by priority: the accelerometer and gyroscope, magnometer and altimeter. So it's a 6-axis IMU sensor, which means that it gives 6 values as output. I suppose I have to read this for me to be able to understand what the code's doing, right? Although I can already imagine what this code's going to look like. 3 values from the accelerometer and 3 from the gyroscope. The MPU-605 is a sensor based on MEM's microelectromechanical systems technology. Both the accelerometer and the gyroscope is embedded inside a single chip. Actually, there's a lot of repetition going on here. An accelerometer works on the principle of piezo. I know how to say that word. I learned that in my first year. Piezoelectric effect. Here, imagine a cuboidal. Oh, bloody hell. It's like imagining stuff. A box having a small ball inside it. The walls of this box are made of the piezoelectric crystals. Whenever you tilt the box, the ball is forced to move in the direction of the inclination due to gravity. The wall with which the ball collides creates tiny piezoelectric currents. There are totally 3 pairs of opposite walls in a cuboid. Each pair corresponds to an axis. Okay, that makes sense. Depending on the current produced from the piezoelectric walls, we can determine the direction of inclination and its magnitude. Yeah, that makes sense to me. So you got a ball there. So you'd have a higher voltage here and a lower voltage here, and then that would tell you that, you're tilted to the right. Okay, how does a gyroscope work? Bloody hell, they're not messing about here, are they? Gyroscopes work on the principle of Coriolis acceleration. Imagine there is a fork-like structure which is in a constant back and forth motion. It's held in place using piezoelectric crystals. Whenever you try to tilt this arrangement, the crystals experience a force in the direction of inclination. This is caused as a result of the inertia of the moving fork. Did they mean like, a fork as in like a mechanical object, or did they mean a fork as in what you eat food with? The crystals thus produce a current in consensus with the piezoelectric effect, and this current is amplified. The values are then refined by the host microcontroller. I'm ready for this tutorial to be over already, to be honest. Oh, thank you. Straight onto the schematic, which I like. So we're using 3.3 volts here this time. It looks like it's got 3.3 volts ground, and then it's got an SDA and SCL pins, and it's got an int0 and int1 pins, which we're not using. So the SDA is going to analog pin 4, and the SCL is going to analog pin 5. So nice and simple. And it looks like we're not using a breadboard again. Interestingly enough, they mention here that the A4 and A5 analog pins are duplicated on the other side of the board. So they're not connected them here to these two pins. They've actually connected them over here, which is interesting. So probably, how do you know which one's which? So here, SCL is going to pin 5. So it's pin 5 at the top, and the next is pin 4. Okay. So we need the MPU-6050 library installed. And then we're just going to literally run the code and open the serial monitor. And we're going to be faced with this scary looking bunch of numbers. All right, let's build the circuit then. All right, so I'm fairly certain that I'm going to struggle to find this sensor again. Oh, just to mention, actually, if you guys have this kit, I PVA glued this thing down, which I feel like it should have been stuck down anyways. Just every time I opened it, it kept on falling out, so I did that. But anyways, let's find this sensor. That's not it. Potentiometer. Ah, this must be it. VCC ground, SCL, SDA, XDA, XCL, AD0, int. Yes, this is the one. We are only using the top 4 pins. VCC, so to 3.3, ground, and then we're going analog pin 5, analog pin 4. Cool. And yes, this time we need female to male. All right, so usually I color code, but I'm not going to in this instance. I'm just going to keep VCC and ground black, and then I'll just use 2 random colors, blue and yellow, which, I mean, they kind of closely match the schematic, but not really. Okay, so VCC up there, holding it upside down by the way. And then the ground. And then let's go with the blue, the yellow one here, which is for the SCL. And then finally we have the SDA. Cool. Okay, so 3.3 volts for the VCC. Ground is always the ground. Okay, so we're saying SCL is going to analog pin 5, which they've said is replicated on this side here. As you can see there, SCL and SDA, literally the exact same names. There you go, SCL and SDA, the exact same names over there. So this is on the digital side of the board. So we'll use this. We'll use the SCL to go to SCL, which is our yellow in this instance, and then SDA, which is our blue, into the SDA. Okay, so let's get our code. MPU. I'm gonna try and run it without the library because it seems that I always have the libraries installed. But if you don't know how to add the library, you just come up to the top of the Arduino IDE, and then you click sketch, and then include library, and then .zip library. So let's try and upload. See what happens. Okay, so that worked for me. So that shows that I've already had the library installed. So we'll open up our serial monitor now, and we've got GYZ spitting out a 3-digit number, sometimes 2-digit, over and over again. Okay, let's try and, wow. So as I move it, the numbers increase rapid. So let's try and understand it together. For some reason, I'm not confident at all that I'm going to be successful in understanding this. So let's skip the setup part for now, where it's just setting up the program and looks a bit complicated. Let's try to go to this void loop. So wire, what's this wire have to do with wire.h? Okay, maybe that's just what we're calling it, wire, I don't know. Wire.begin transmission MPU address. Then we're writing to this. What is it? What do you call it? Is it a structure? Function structure? End transmission, wire request, ACX wire read. Okay, so for whatever reason, we're only currently printing the GYZ, which I'm not sure what that's referring to. The GYZ is that the gyro G. Sorry, the gyro Z. That's what we're only printing, but they've commented out these ones. So let's remove these comments so we can just get basically the full data that we want, which is our, I don't really understand, but accelerometer plus gyro sensor. Let's just hit upload here, and then at least we'll get all of this information here. We might need to add some new lines to stuff to make it make sense a bit more. So let's now check out what we're printing. Okay, so we're printing all of this. So this obviously again is too manic. So let's add a delay in here. Delay 1000. Upload that again. Okay. All right, there we go. So even that's is still too much to be able to read. Let's make it 5000. Okay, so let's take a look at our serial monitor now. All right, so we've got everything kind of still printing a little bit random. If we can get it all on one line, that would be helpful. So it seems like we've got a new line after this ACY. So let's check this out. So ACY, and then it's printing a new line for some reason. Okay, so I'm not sure why it's printing onto a new line. Let me just try and clear some stuff up here. So firstly, this is the accelerometer, right? Okay, and then this is the temperature, and this is the gyro. So I'm gonna need to firstly, I don't understand what an accelerometer and gyro is. So let's call that temp. I've just added some spaces here. I've added 2 new lines there. So I want to try and get this readable to some degree. So if I do serial print, and then, so it seems like we're printing the temperature. So let's put here, I'm going to put Celsius. Now, the only thing I'm thinking there is that it seems that every single time it prints one of these, it creates a new line for itself. I'm not sure. Let's just see what happens there. Maybe that Celsius won't work. Okay, so the Celsius worked fine. 2.35 Celsius. Printing this final GYZ. Oh, okay, yes, of course. Yes, it's printing out onto new lines because I've obviously put these 2 new lines here. But that's before it's printing this GYZ value. So let's, again, right now, in case you're wondering what's this guy doing, I'm just trying to firstly clean up what it's printing so that hopefully my brain will be able to figure out what's going on. Right now, I'm getting spat out a bunch of numbers. I feel like my first lecture in electrical engineering, first year and second year, where I looked at the board and said, is this even English? Okay, so it sucks that it's printing this onto a new line, but what can I do? It's fine. I have to move on from it. Let's check what an accelerometer is first of all. Accelerometer. How do you spell this? Oh dear, that is definitely not how you spell it. Accelerator. Accelerometer. Okay, so that's actually what it looks like. It looks like exactly like that. So an accelerometer is an electromechanical device used to measure acceleration forces. Such forces may be static, like the continuous force of gravity, or as is the case with many mobile devices, dynamic. Okay, so it senses acceleration. Okay. And then so it's going to be acceleration to the X. I don't know what way that is. Acceleration to the Y, and acceleration to the ZZ. Okay, so what's a gyro? Gyro has to do with tilting, I believe. Oh dear. Gyroscope. So to look, it's a device used for measuring or maintaining orientation or angular velocity. Okay, so it has to do with tilting to the left and to the right. But what does it mean to tilt to the X, Y, or Z? And what unit does it use? Okay, let's just put gyro there. Gyroscope. What does it mean to the gyroscope to the X, Y, Z axis? What does that mean? Oh, this is actually the picture from the tutorial. Okay, so it's to tilt. Wow, this is okay. This is quite deep. So it's to tilt that way for the X, that way for the Y. So you're tilting basically this part coming up, or this part coming up, or this just going around that way. And so to the minus X is to go with this part coming up. To the minus Y is this side coming up. And to the minus Z is to go back around that way. So this is going to be very difficult to code. And I'm assuming that you would just use some sort of library that has done it all for you. But let's try and do something. Get some kind of understanding it. Okay, so accelerometer X. So so we've got temperature here. So firstly, I suppose, how is it working out temperature from that? Okay, so I'm going to hold it and just see my fingers and see if it heats up. Currently 24. Wow, yeah, okay, shot straight to 28.9. How does it calculate temperature from that? 30.5, 31.5. Oh yeah, it's working fully. Okay, so let's see if I just let go. How long does it take for it to drop? It already started falling. This temperature is more accurate than the other one. 31. Nice, yeah, look, the temperature falls very quickly. Okay, so now let's try and understand the accelerometer part. So if we don't know which way would be X, Y, or Z, I'm wondering if maybe it might be worthwhile to just not print anything else other than, so for example, like maybe just print just the X. No, make it easier to see what you're doing, right? And let's decrease the delay. We'll do it every 1 second. Okay, so now I just want the accelerometer X value. So I should be able to easily work out from here what are the oh, it's not printing onto a new line again. So with the device this way, which is, basically correctly orientated towards us, so towards you, the camera, and it's facing upwards. So if I move it this way, do I get much movement? Yeah, I do. I get loads. So that's X then. So what if I go this way? Um, Still a lot. Okay, what about up and down? I mean, you're still getting fluctuations of over 1,000. So how does this thing work? X. Okay, we'll try and print just all the accelerometer stuff. Okay. Even so, okay, so this way the Z one's not moving too much. Z is staying at 19,000, 16,000. So Z's not moving too much that way. So which one is moving the most? 496 to over 1,000. Y is moving a fair bit as well. I know that I am obviously moving each part because my hand's not perfectly moving side to side. But you can see Z's not moving that much. What if I go up and down? So we had a bit of a fair jump there in Z. I can't do it. I can't work out what if this is gonna take way too long. Okay, so Z. Okay, so Z's not that way. So which way? Which one? So this way is Y. You can see that you're getting 5,000 minus 10,000, 15 minus 15,000, 19,000, 7,000 minus 22,000. That way is Y. Okay, that way is Y. This way must be X, right? Yeah, you can see X is going from 16,000 to minus 16,000. So for example, like that way, so you should get, okay, so this way is minus. You see, so if I move fast that way and then slowly back this way, you can look at X. So, okay, this is positive X, this is negative X. This is just like the joystick again. Yeah, man. This is next level stuff. The fact that people firstly designed this, and then secondly, normal weirdos like me actually understand it. I mean, I don't understand this, but I'm sure a lot of you guys do, and um, a lot of these Arduino hobbyists obviously get this stuff. Okay, so that's the accelerometer. I didn't quite get Z. Z is up and down then? Doesn't make sense. Z must be up and down, right? Okay, there you go. Got a big fluctuation there. 32,000, 12,000. Okay, so we've got X, Y, Z. Oh, yeah, that was difficult. So I can't really be bothered to do the same thing with the gyroscope. Go on then, I'm gonna do it. Okay, so temperature seems to be super accurate, which is amazing. The accelerometer seems to be, working well. So let's put accelerometer and temperature on new lines, and then delete this, and then let's put the gyroscope on a new line as well. Try and make all of this more readable. Okay, so gyroscope has to do with tilting that way, this way, and what's the other way it can tilt? This is going to be X, that's going to be Y. How else can it tilt? That way, like that. Am I losing it? How else can it tilt? Let's have a go on Google again. Oh, this way. The accelerometer, temp, gyroscope. Let's make some more space between our code because I just can't see. \n and then \n. Now to get a bit more clarity. Okay, there we go. So our gyroscope now is minus. Well, it's gone from minus to minus 447. I can't read this too fast. Okay, make it 3 seconds. So okay. So Z should be spinning this way. So we're at minus 96. So we're fluctuating between like 0 and 3000 basically. So if I just turn it this way. Okay, there we go. So you got the 9000, 6000. We're gonna get a positive huge number. 7800. There you go. So that's the X. Wow, 32,000. Okay. So that, sorry, I just said that was X. That's the Z, right? Okay, now X. So X is fluctuating, around the thousands, 0, anywhere from like, let's say minus 1,000 to 3,000. So if I tilt it up like that, you'd get big movements. There you go. Look at that, 18,000, 5,000, 24,000. That's definitely X. So for example, if you had a robot, you would want, like, for example, you would want it to react to small amounts unless you had some amazing robot and amazing code. But I would do, for example, I would know if I'm going uphill if I had a minus 20,000 change in my X value. Or would that have to be quick? Or does it just have to be just a change? I don't know, because look, we're still fluctuating 1,000, 2,000, minus 6,000. Look, 608, 64. Or is this Y? Oh, this must be Y. Because look, Y is 15,700, 11,000. So you would say, okay, we're going uphill if we have a 5,000 change in our Y. You could be getting downhill as well. Quite difficult for me to understand this actually. So this, it should be X. So X like this, 15,081, 11,000, 9,000, or 1,100. 12,000, 2,500, 8,200, 16,000. There you go. But Y is still fluctuating like crazy as well. And really, I'm not tilting it like that much. It's difficult. I mean, let me know if you find this easy. I certainly don't. I'm intrigued by the temperature one. That's quite cool. Other than that, that was I'd say that was a fairly difficult program. I mean, that wasn't easy. All right, well, this is going to be one of those where you have to just take it on the chin that you don't really get it. What can you do? And you just move on. And, again, I'm sure moving forward, when I go through some books and stuff, I will find this. I'll come across this sensor again. And hopefully I'll have someone, decent who can teach me and tell me about it. But for now, I kind of get it. The gyroscope with the X and Y values are little bit finicky. Z worked perfectly, and accelerometer, obviously, we understand. So, yeah, it's all good. All right, guys, I shall see you in the next one. As always, I say that before checking what the next one actually is, which is the HC SR501 PIR sensor. Yeah. I got no clue. So, yeah. All right, guys, I'll see you in the next one. Take care.